Very good morning to you again, and welcome back to another session of Streaming School. We hope you are finding the interim activities and the backlog of videos really, really useful. I will be permanently apologising for my haircut at the start of every lesson, and you all know why it's this way. But now it's got flecks of grey, and some parts are up, some parts are down. And maybe there's something that gel or a brush could fix. But I'm not into technology, so I'll leave those new technologies for hair care to another side. What do you reckon if I got some straighteners out, Nish?
I think you should. Man, if I could come and straighten your hair, that would be the best thing ever.
That would be like, you know what? I think the girls would probably like to do it. My two others would like to do it, but they probably singe me to death, Sam. So yeah, I just come in with all burn marks all over my face. I look like a weird chopping board experiment with a hair straightener. So yeah, it's probably not a good look. How are you, buddy?
Yeah, move nicely on to me, of course, whilst we're talking about hairstyles. Cheers, Leon. I'm extremely good. Thank you. And yeah, I've had a fresh shave this morning.
Yeah, well, some people have got all the luck, haven't they, Sam? What are you going to do with your unlimited exercise routine, buddy?
Today, I don't know. I'm looking out the window now, and it's not looking very fun. But I'm sure a cycle or a run of some sort. Who knows?
Fair play. All right, quality, buddy. The screen is about to be yours, and yeah, really look forward to another wonderful lesson with you.
Brilliant. Cheers, Leon. Cheers, Nish. Okay, so welcome back, guys, to GCSE Maths. Today we're going to look across a variation of both scatter graphs and transformations. Of course, with no session Friday, we've got a lot to pack in today. But Nish, if you can share my screen, please.
All right, cool.
And as you can see, to start off with, just a quick recap of what we did on Wednesday last week. Feels a long time ago now. We've got the probability scales that we started off looking at, and remember, probability is always based from 0 to 1, so you must complete 100% when filling out probability scales. So we've got 0.2, 0.35, 0.05, 0.25. Of course, the remaining total will be 0.15 for black, because that all adds up to 1. Then we looked at relative frequency on the right here. So you've got information, you've got a set of data. You've just got to answer questions based on that. We also looked at probability trees. Remember, when looking at two outcomes, you just multiply the fractions. So, for example, I think one of the questions was, what is the likelihood of getting 2 3s when spinning a spinner twice? And you just multiply 1/4 by 1/4 to give you 1/16. So 16 attempts, you're likely to get 2 3s once. And then finally we had probability of events occurring. So we use the words impossible for 0, unlikely for anything between 0 and 0.49 or 0.5 perhaps, and even chance is 0.5, and then likely is anything beyond even or even chance, and then certain, of course, is 100%. Okay, so that was probability of events occurring. Today we're going to move on to scatter graphs. And as I said, at the end, we will see if we can fit in some transformations, but if not, we can just pick it up on Wednesday. Today, we're going to look at interpreting scatter graphs, plotting scatter graphs, interquartiles of a set of data. So that's where you find the median, you find the lower quartile and the upper quartile. We draw a line, accurate lines of best fit, and then again, we're on to transformations. So looking at rotation, reflection, translation, and possibly, if we get time, we'll look at some enlargement. But the first thing I'm going to do is share with you my screen, my visualizer, and we're going to look at just a couple of the letters in the graph on the left-hand side and how we're going to write the coordinates. So, of course, we look at the x-axis first. So if I was to find the letter A, then we would go along the x-axis to 6 here, and then we go up the y-axis and we find 5. Okay, so in terms of coordinates, let's do a few more. If we find B, which is right in the top corner here, we go across the x-axis, along the corridor, up the stairs, so that's 8, and we go up the y-axis and across to 9. And then finally, the letter C. Again, you go across the y-axis, across the stairs, give us 2, and we go up the y-axis to give us 4. Okay, so it's really important that you're able and really confident with, assuming actually, really confident with labeling your coordinates. But with scatter graphs, we're going to look at something today called vectors. Okay, and vectors, especially when we look at transformation, that is where a shape is moved in a particular way. So when we look at translation, a vector might look something like this: 5 and 8, which means 5 to the right and 8 places up. Okay, but we'll look into vectors shortly. Okay, so scatter graphs. Lots of different ways of describing a scatter graph. First and foremost is the correlation between the plots on the scatter graph. So here on the left-hand side, you've got the test scores up the y-axis, and along the x-axis is the time spent doing homework. So what is the relationship? The question might be, what's the relationship between people doing homework and their test scores? Well, of course, the longer they spend time on the homework, so the more minutes, as minutes increase doing homework, the likelihood is that they're going to get a better score in their test. And you can see that this is going up from 0 minutes doing homework, if you will, going up to a lot of minutes. We don't know exactly how much because it's not giving us data down there. However, that is called positive correlation. So if the general term is that all the plots are going up, then we call it positive correlation. So if both axes are increasing, again, positive correlation. In terms of how accurate it is, well, for me, that's strong positive correlation, because all the plots are following the same pattern, and if we draw a line of best fit, they would all be very, very close together and really well grouped. If you look on the right-hand side, again, I would say positive correlation. However, it's extremely weak because the plots are scattered around the scatter graph, which tells us that's weak correlation. Now, of course, the opposite of positive correlation is negative correlation, and that is when one axis increases, the other one decreases. So here, as the rainfall increases, the temperature decreases. So therefore, we're going down, if you will, from the y-axis to the x-axis, it goes down, and that's negative correlation. Again, on the left-hand side, it's a strong correlation, but it'll be strong negative correlation. Again, on the right-hand side, a little bit stronger than the previous slide. However, it will still be weak negative correlation because of how scattered the plots are. Okay, so I've got a few examples here, and we're going to just list A, B, C, D, and E. But also, first, don't forget you can have no correlation whatsoever. So this information on the left-hand side, in terms of someone's IQ, has absolutely no relevance to the house number that they live in, of course. So therefore, there is no correlation here. And if we were to go through, again, if I'll call them out. If we look at A, we would say negative correlation. And in terms of weak or strong, but you can also have moderate. So there's a chance there, for me, it would be moderate negative correlation. If we look at B, for me, absolutely no correlation whatsoever. C also, no correlation. D would be definitely positive. It goes up and they're extremely strong. So it'll be strong positive correlation. And finally, E, if we look at E, again, it goes up, not as strong as D. So that would be moderate positive correlation. So 3 types of correlation: weak, moderate, and strong. And then you've got positive, negative, or no correlation whatsoever. So it's important that you know those terms of correlation for your GCSEs, as you will have to describe scatter graphs when seen. Now here's just a little example for you: the number of firemen fighting a fire and how big the fire is. So we expect that the size of the fire increases, the more firefighters are needed. So of course, therefore, the correlation we would assume would be positive and relatively strong. So we would say strong positive correlation for that one. And the next example, one more, we've got the length of someone's hair, common theme today. The length of someone's hair and their shoe size. Absolutely no correlation whatsoever. Okay, now we're looking at lines of best fit. So here you've got some information on the right-hand side. But first and foremost, a line of best fit, as you can see here, is a straight line that represents data. And although some people think that you have to start at the y-axis, or you have to start at 0, or you have to start at a particular spot, that's not the case. As long as it passes through as many of the points as possible, and you're really looking to draw a line that helps you estimate future scores. So for this example here, in fact, if I flick through there, you can actually see a line of best fit that I drew to represent the data. Now, of course, you've got this plot here, but that's completely not necessarily irrelevant, but that's from a student that may have done their maths exam and missed the science exam. That might be what that plot there is telling us there. And just ignore it when you come to your line of best fit. If there's one or two that are far away from the rest, we still look at the strong correlation data. So here you can see you've got sun just above the line, sun just below, and that'll be our estimate. And actually, if we go back to that line, if I was then to ask a question, if a student scored 50 in science using your line of best fit, what would your predicted score for them to be in maths? So we find on the x-axis you've got the science marks of 50, and if we go up the line of 50, you can see here, and we hit it halfway. As we go across, we'd use our ruler now to go across, and we would say that they would score, our estimation would be that they would score 55 on their maths mark. Okay, so that's the benefit of doing lines of best fit. You can then predict quite roughly, you can predict and estimate future data. And here we've got an example on the left-hand side for a previous GCSE question. And it says, the first one says, write down the type of correlation shown by the graph. So of course, we know that we spoke about positive, negative, or no correlation. Well, it's going up. As one increases, the other increases, so it's positive. And then we would describe that as either strong, moderate, or weak. For the GCSE answers here, if you to use moderate, strong, weak, they've got the word scattered as well. It says ignore, so you wouldn't lose any marks if you wrote that word, and you wouldn't gain any extra marks. So just the word positive would suffice for now. And then for letter B, question B, it says the manager expects the sales of umbrellas next month to be £60. Draw a line of best fit to estimate the sales of raincoats. So therefore, again, we've just got to try and hit as many of the points as possible, or certainly give an accurate estimation using our line of best fit. And you've got some information here in relation to the answers. But the main answer, of course, is that if we were to find £60 in terms of the umbrellas, you need to go up and hit your line of best fit, which would be around the 125 mark here, where you can see my red toggle is on the screen. And they also give you in the GCSEs, they often give you a degree of variation in terms of your answers. So if you were to say exactly 126 or 125, you would still get the marks because it was within a certain number in terms of the answer. Okay, so we're going to move now to interquartile. Now, interquartile range is basically the data within the quarter and the 3 quarters of information. So you first of all find out that the middle number in terms of the data. So it first of all says the interquartile range looks at the spread of the middle 50% of the data. So here you find that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So if we were to find the middle number here, of course it would be number 6. So you've got 5 now on either side. And I guess finding the median number will be a lot easier when you've got odd numbers of data. If you were to find even numbers, so for example, if they had 10 sets of data here, then you'd go in between 5.5 and 6. Now, the median, as it says here, is the value halfway along the list, and the lower quartile is a quarter of the way. So here, if we looked at a quarter of the data, it would be the number 50, and if we looked at 3 quarters, it would be the number 53. Okay, and using that information now, you can find the interquartile range. So I'm going to give you, I'm going to show a worksheet on my screen. And I'm going to plot some information and use this information to find the interquartile ranges on the scatter graph. So first of all, it says we're going to plot information. So we look at 1, and we've got 60. Then we go 2, and we've got 80. 3, we've got 104. 4, you've got 116. 5, 128. 6, you've got 140. And 6 again, you've got 160. So you can see that straight away our graph is positive correlation. And if we were to join them up, which we won't because that's a line graph, but if we were to join them up, it would be positive correlation. And what we're going to do now is describe the correlation. So we're just going to write down here at the bottom of my page, positive. And although on the last GCSE answer, it did describe, you just need to use the word positive as opposed to weak, moderate, or strong. But we're still, just to be sure, use the word strong correlation. Okay, so what I want to do now is draw a line of best fit, draw a line of best fit even. And again, remember, you don't have to go from the y-axis, but we're looking to go through as much of the data as possible. And I'll just plot, just make sure you do go from beyond the start and to the finish. So as you can see, my line of best fit shows that there's a few scattered just above the line, and there's a couple scattered just below. And then finally, it might say, what number haven't we used here? We haven't used 4, for example. So if someone was to work for 4 hours, what would they charge as a plumber? So we would find 4 in terms of here. I'll use my black pen, that may be better. And if we were to go up and using our line of best fit, we can tell actually if we went across, we would charge there 116, which ironically is that one which should be there. That's one. So it's important, first of all, that you read the information on your screen, on your sheet, but then also accurately use your line of best fit to predict future data. So if the question was to say, if a plumber works for 4 hours, how much would they charge? And we just draw straight up, vertically, hit the line of best fit, and then go horizontally towards our y-axis, and we get the answer of £116. So we've described the correlation, we've accurately drawn it, and also now we could probably look at interquartile range. I think we've got 1 more minute to look at interquartile range. So our median number here would be the 1, 2, 3, 4, 5, 6, 7 sets of data. So we would find this number here, which would be the median, and our lower quartile would be here. Just put LQ for lower quartile, and our upper quartile here would be 140. So the interquartile range would be between the two, so between 80 and 140. And in terms of showing that on data, well, first, if we go back to this, we look at 2, and we go up, and we hit our line of best fit. And if we go to 6, and we go up, and we hit 140. And then all the interquartile range, of course, sorry, I should go there. Of course, all this area here, and they might ask you to colour it in, shade it in, or just show on a graph. So the interquartile range is the difference between the lower quartile and the upper quartile. That's not quite done to 80 there. That's what it should be, sorry. So that's your interquartile range, the difference between the lower quartile and the upper quartile. But Nish, if you can share my screen now, please.
All right, cool.
So I hope you enjoyed today's tutorial. So we went through scatter graphs. We didn't move on to transformations, I'm afraid, which I think is one of the tasks following later on. However, we can look at transformations on Wednesday's session. But have a good day and stay safe.
Thanks, buddy. Really appreciate it. You too.
Cheers, Leon. Yeah, have a good one, mate.
You too. Bye.